Hello everyone, welcome back to class. I'm so excited to have you here again. Last week we talked about organic chemistry. I explained the definition of organic chemistry and I also mentioned the uniqueness of carbon. Under that I talked about catenation of carbon and also its tetravalency. I went on to talk about the importance of organic chemistry. Today we are going to look into classification of organic compounds. Organic compound constitutes about 90% of all the chemistry compounds. That's quite a lot, isn't it? In order to study such vast number of compounds, it is necessary to classify them into categories. Now, that will lead us to classification of organic compounds. Organic compounds can be classified majorly into two. We have what we call cyclic compound. Cyclic compound can also be called closed chain compound. Then we also have what we call acyclic compound. Acyclic compound can also be called open chain compound. Some people even call it aliphatic compounds, Now, this cyclic compound can also be subdivided into two again. We have what we call homocyclic compound or carbocyclic compound. We also have what we call heterocyclic compound. Now, this acyclic compound also can be divided into two parts. We have what we call saturated compound and unsaturated compound. Now, when you look at it, we have a lot of categories of organic compound. But don't worry, it may look somehow complex to you, but by the time I start explaining it one after the other, you will really understand what they are all about. Now, let's start from cyclic compound. When we say cyclic compound, they are organic compounds in which the carbon are linked together to form what we call a loop or ring. What do we mean by that? When you have a carbon atom, let me give you an example of cyclopropane. Cyclopropane looks like this. Then we have H2 here, H2 and H2. This is an example of a cyclopropane. And when you look at it, it looks like a chain, a normal chain that a woman uses. And you want to hook the chain. It will look like a circle. It may not necessarily be circle. It may give you any other shape, but they are just in form of a ring. That's a cyclic compound. Then we also have what we call acyclic compound. Acyclic compound is a type of compound in which the carbon are linked together to form either a straight chain or what we call a branch chain. Example of that is butane. Butane is a 4-carbon atom compound. When you look at this, you can see that the carbon are arranged in a way that they are straight. And that is why we call it a straight chain carbon. When we now say branch chain, let me give you an example of a branch chain. So this is an example of a branching. This one is called butane. Why this is called 2-methyl propane. So these are the example of acyclic compound, which are compounds that are formed when carbons are linked together on a straight chain or branch chain. Now, let's go back to our cyclic compound. Remember I told you that the cyclic compound can also be subdivided into two, which are homocyclic or carbon-cyclic compound and also heterocyclic compound. So let us look at what homocyclic or carbon-cyclic compound are. When we talk of homocyclic compounds or carbon-cyclic compound, they are compounds that contains a ring structure in which the ring is majorly made up of carbon and hydrogen atom. Example of such compound is called benzene. Benzene looks like this. Don't worry, I understand. You'll be wondering what is it that I drew on the board. Let me draw it skeletally for you. It's like this, like this, like this, like this. Hope you are seeing it like this and like this. So each point here stands for carbon. Then after that, there is a double bond here, a double bond here, and also a double bond here. Then after that, we have invisible hydrogen atom all around it. Don't worry, as we move on, you tend to understand all these things. But when you look at the structure of a benzene, this is the structure of the skeletal structure of a benzene, you will see that all of the compound, throughout the compound, we only have carbon and hydrogen. And that is what homocyclic compound or carbon-cyclic compound is. Then when you also look at it, you see that they are in a ring form. That means they are not straight and they are not branched. So that is an example of homocyclic compound. Then this homocyclic compound can also be divided into another part. We call it aromatic compound. When we say aromatic compounds are compounds that consist of one or more rings. Remember, I said one or more rings, which have alternating double and single bonds. They consist of one or more rings that have alternating double and single bond in their structure. I'm still going to give you an example of benzene or toluene. Maybe we should just pick toluene since I've mentioned benzene before. Toluene is more or less like benzene, but the difference between the two is that toluene has extra methyl group. Here, remember, this is the structure of benzene, then toluene now has extra methyl group. When you look at this structure here, is a ring structure, that is number one. Then they have alternating single to double bond. This is a double bond here. After the double bond, we have the single bond. After the single bond, another double bond. After the double bond, single. After single, double. So that is why we call them aromatic compound. Then, let me give you an example of a compound that contains two rings. And that compound is what we call naphthalene. Naphthalene is like this. It has a one ring like this, and another ring is also joined to that ring to make it two. Then we have it like this, like this, like this, like this, and like this. So this is an example of another aromatic compound, which is called naphthalene. I believe it's clear, and I think it's not that complex. Yeah, because of the structure, right? We are just starting, but as time goes on, you tend to get used to those structures and stuff. Then let's now move on to what heterocyclic. So under aromatic compound, we have what we call benzenoid. Aromatic compound can also be of two types. Sorry. We have what we call benzenoid compound, and we also have what we call non-benzenoid compound. When we talk of benzenoid compound, they are compound containing benzene ring. From the word benzene, it forms benzenoid. So all compounds that contains benzene ring are called benzenoid compound. Example of that is the same benzene that we have. Naphthalene is also another example of benzenoid compound. Then when we talk of non-benzenoid compound, they are compounds that do not contain benzene ring. Now you are wondering what type of compound is that. I'll give you an example of that. An example of non-benzenoid compound is called pyridine. Pyridine is like this. Then we have here, here, and here. This is called pyridine. That is an example of non-benzenoid compound. Then the last one we'll be talking about is heterocyclic compound. Heterocyclic compound is more or less like homocyclic compound. They are compound that consist of ring. You know, in homocyclic, I said, is a compound that consists of ring structure in which they are made of carbon and hydrogen atom only. But for heterocyclic compound, they are also compound that contains a benzene ring, but this time around they are not made up of only carbon and hydrogen, but they also have some other elements attached to them. Example of such elements is your nitrogen, your sulfur, your oxygen, and so on and so forth. Let me give you an example. I'm going to give you an example of the one I've given you before, which you have now familiarized yourself with, and that is also pyridine. You know pyridine, like I drew it before, it has a nitrogen with the structure of it. So it has a nitrogen along with the carbon and hydrogen structure. So that is that about the classification of organic compounds. Next class, we will go into hydrocarbons. We'll talk about alkanes, alkenes, and alkynes. I can't still wait to see you in class by then. Bye.